Hi, I'm Steve Zoller from KMT Enterprises, and I'm here today to show you the latest attachment for the KMT personal ball jig. It's the KMT DODO-scale attachment, and before I show you how it works, I'm going to show you how it assembles. You start out with the KMT personal ball jig, remove the top plate, then take a Phillips screwdriver and remove the two screws that hold the pitch plate in place. You take the beam attachment and put that in place. Then attach the vertical bar to the beam with two of the Allen screws that come with the kit. Then attach the top plate with two Allen screws. Then take the 3/8 by 5-inch bolt that comes with it and screw that in to the beam from the bottom so that it's sticking out the top. Then attach the bearing holders with the same thumb screws that came with the ball jig. Then attach the two bearings to the top horizontal bar just by pressing them in place. Then set the whole thing in place on top of the ball jig. Put the slide weight in place on the beam, and you're ready to get started. Here's how it works. Before you put a ball in the cradle, there are two blocks that come with the scale that you can set underneath each end of the scale to stop it from bouncing around too much. Now I've got a 12-pound ball here, and I'm going to put the ball in the cradle on this side, and then we have to put 12 pounds worth of counterweight on the other side. The scale is not designed to weigh anything less than a 12-pound ball, and it's not designed to give you a gross weight readout. Since most all high-performance balls are 12 to 16 pounds, I've only designed it to weigh 12 to 16-pound balls. And since when you're dealing with a drilled ball, you're not concerned with the gross weight, you're concerned with the offset that's inside of the ball, I've only designed it to weigh the offset of the ball for a maximum of 5 ounces. So what we're going to do is set the CG on this ball towards the inside, and the CG you can see is right here, and we're going to point that in this direction. And to make sure you get the ball perfectly level, you can place this block in front of it, which comes with the kit, and line the CG up with the top of that block. You have to remember that you're always weighing the outside half of the ball. And in this case, I've got the outside half of the ball as the light half of the ball. So I'm going to place my sliding weight in a position where I can increase the weight when I switch the ball around. All right, so now we can take the blocks out. And what we have to do is balance the scale so that this bubble is right in between the two lines. And as you can see, we've got a little bit too much weight on this side, so we need to add washers on this side until the scale balances. And there are 3 different size washers that come with the kit so that you can make sure you get it balanced perfectly. Now we're going to start with a couple of big ones. Okay, it looks like we need a little bit more here, so we're going to add some of the smallest washers. Okay, it looks like we still need just a little bit more here. That looks just about perfect. All right, now that we've got the scale level, what we need to do is flip the ball around 180 degrees and weigh the other half of the ball. So what we will do slide this block back underneath here a minute so the ball doesn't flop around too much. Put the block on this side of the ball and line the CG up with the top of the block again. Now we need to rebalance the scale, but this time we're going to use the sliding weight to see how much weight this side of the ball has got compared to this side of the ball. The way I've designed the lines on the beam are, the longest lines are 1 ounce increments, and all the lines in between are 1/4 ounce increments. Since there are no numbers on the lines, because you can start on any line that you want to start on, what I've done on this particular model is I've taken a colored pencil and just colored in the 1 ounce marks so you can keep track of where you were. And we're starting on the purple line here, and we're just going to slide the weight over. Now with this particular ball, you can see that with the scale leveled, we ended up moving it 3 increments on here to the red mark, which is just under 3 ounces. So this ball's got 3 ounces of top weight. If you were checking a drilled ball for top weight, side weight, or finger weight, this is how you would use the scale. Let's put some blocks under here first so this doesn't flop around. And then let's take the ball that we've got here and let's set this up as if it were drilled. And let's say that we were going to set it up like this. And let's say that we're using this as the center of your grip, and this for your fingers, and this for your thumb. So you've got your thumb here, finger here, and a finger here. Now what you would do is put the ball back in the scale like so. Now let's say we're going to weigh for side weight. Okay, what you want to do is take your block again, set the other block underneath here so it doesn't bounce around, and you can line the center of your grip up by using the span ruler that came with the ball jig and the block that comes with the scale until the center of the grip lines up with the top of the span ruler. Then you know you've got it centered in the jig the way it's supposed to be. And then what you're going to do is set the sliding weight exactly on one of the marks, and you can choose any mark you want. We'll just leave it set here on the red one. Level the scale again with the ball in this position, then flip the ball around 180 degrees. Re-level it again by sliding the slide weight until the bubble levels out again. And that'll tell you how much difference there is from one side of the ball to the other side of the ball. The incremental lines on the balance beam have been mathematically calculated and they are accurate. However, it does take a human being to physically place the ball in the cradle and actually level out the balance beam. Therefore, there is room for human error. I would caution you, especially if you're a novice driller, not to run your tolerances too close to the maximum allowed limit that is allowed by USBC. For instance, you're allowed to have 1 ounce of difference from one side of the ball to the other side of the ball. What you should probably do is run your maximum tolerance, instead of going exactly to 1 ounce, you might want to go to 3/4 of an ounce or 7/8 of an ounce. Make sure that your final drilling has something a little bit less than 1 ounce, just to be on the safe side. The KMT DODO-scale attachment sells for $199 plus shipping. It will allow you to accurately weigh your ball and make sure that it complies with USBC static weight requirements. For more information, send me an email at kmtproshop@hotmail.com.